Welcome to these gentle, soothing stories for sleep. I am so glad you are here. Whether you are preparing to drift off to sleep, relaxing after a long day, or simply seeking a quiet companion for your thoughts, you have found a soft place to land. Tonight, we will embark on a journey of the imagination, a thought experiment to a world both strangely familiar and profoundly alien. We are going to visit a planet without rain. Before we begin our journey, I would love to know where you are listening from tonight, or perhaps just a word about how your day has been. Please feel free to leave a gentle comment below. Wherever you are in the world, I hope you are feeling comfortable, relaxed, and ready to explore something truly extraordinary. And if you find these soothing scientific journeys a pleasant companion in the quiet hours, please consider liking this video and subscribing to the channel. It helps other souls who are searching for peace to find their way to this quiet corner of the world. Imagine a sky that never weeps. Imagine an atmosphere that holds no promise of a storm, no memory of a cloud, a sky that has forgotten the color grey. Here, on this silent world, the dome above is a flawless, unbroken blue, a hue so deep and so persistent that it feels less like a gas and more like a solid thing. A vault of sapphire, arching from one horizon to the other. The sun moves across it day after day, a perfect golden disk in a sea of absolute clarity, its light unfiltered and sharp, casting shadows with edges as keen as a blade. The air itself feels different, not just on the skin, but in the lungs. It is thin and sharp, carrying with it a constant, almost imperceptible taste of fine dust, the taste of stone and minerals, with no hint of the damp, earthy scent of life that we know. To breathe it in is to feel a deep and abiding dryness, a sense of being slowly, gently, and inexorably wicked of all moisture. On Earth, our world breathes. It has a pulse, a great and powerful circulatory system known as the water cycle. It is a rhythm we are so accustomed to that we rarely even notice its ceaseless beat. Sunlight warms the oceans, the lakes, the rivers, and even the damp soil, coaxing water to rise as invisible vapor. This vapor, lighter than the air around it, ascends into the cooler heights of the atmosphere, where it gathers and condenses, transforming from a gas back into microscopic liquid droplets, forming the soft, brilliant white clouds that drift across our skies. And when these droplets have gathered enough, when they have grown heavy with their own potential, they fall. They return to the earth as rain, a gentle baptism that replenishes the oceans, nourishes the soil, and washes the air clean, before the cycle begins once more. It is the planet's heartbeat, this steady rhythm of evaporation, condensation, and precipitation. But here, on this world we are visiting, that heart is silent. The vast machinery of the water cycle has ground to a halt, or perhaps it never began. The silence it leaves behind is profound, a stillness that permeates everything. The deep, unchanging blue of the sky is a direct consequence of this stillness. The blue we see on Earth is the result of a phenomenon called Rayleigh scattering. As sunlight, which contains all the colors of the rainbow, enters our atmosphere, it collides with the tiny molecules of gas. The shorter, bluer wavelengths of light are scattered more effectively than the longer, redder wavelengths, bouncing around and filling the sky from every direction, which is why we perceive it as blue. It is like pouring a stream of mixed-sized sand through a very fine sieve. Only the smallest grains, the blue light, get bounced around, while the larger grains, the red and yellow light, tend to pass straight through. On our rainless world, the atmosphere is exceptionally thin and dry, almost entirely devoid of the water vapor and larger aerosol particles that populate Earth's air. This purity means the Rayleigh scattering is even more pronounced, more efficient, leading to a blue that is deeper, darker, and closer to violet, an almost unnerving perfection. This profound dryness would make itself known on our very skin, in our eyes, in the membranes of our nose and throat. Humidity, the measure of water vapor in the air, is a gentle buffer on Earth. It softens the air, slows the evaporation of moisture from our bodies, and helps to regulate temperature. In a place of near-zero humidity, this buffer is gone. Water would leave our bodies with startling efficiency. a constant and silent theft of our internal ocean. We would feel a persistent thirst, a scratchiness in our throats, a dryness in our eyes that no amount of blinking could soothe. We would be profoundly aware of our own composition, of the fact that we are beings made primarily of the one element this world has forsaken. And as we stand beneath this vast, unchanging, and perfect sky, a thought might drift into our minds. We often equate perfection with beauty, with a kind of divine or ideal state. But here, the perfection is a sterile thing. The utter predictability of the sky, the absence of any change, any cloud, any storm, feels like a kind of death. It suggests that life, as we understand it, is inextricably linked to imperfection, to change, to the dynamic and sometimes chaotic dance of the elements. A sky that can never be anything but blue is beautiful, yes, but is it truly alive? As this flawless sun, which has known no cloudy day, begins its slow descent toward the horizon, its light streams across the vast, empty canvas of the sky. What would a sunset look like, here, without the artistry of clouds to paint upon? In a world without rain to wash the air clean, what becomes of the dust? On Earth, a rainstorm is a moment of renewal, a catharsis for the atmosphere itself. Each falling droplet scrubs the air, pulling down dust, pollen, and pollutants, leaving the world feeling fresh and crystalline in its wake. But here, on this dry planet, there is no such cleansing. Every particle that is lifted into the air by the wind, every grain of sand kicked up from the surface, every microscopic fragment of rock from a meteorite impact can remain suspended for centuries, creating a permanent, gentle haze that softens the harshness of the unfiltered sun. The world is rendered in muted tones, as if seen through a delicate veil. The landscape is a palette of ochre, rust, and pale grey, with the sharp edges of distant mountains blurred into soft silhouettes. The light of the sun, especially in the long hours of morning and evening, takes on a tangible quality, streaming in visible, shimmering shafts through the particle-laden air. This is a symphony of dust, an endless, silent dance of fine-grained matter that defines the character of the world. The primary, and indeed the only, artist of this landscape is the wind. Without water to carve canyons or smooth stones in a riverbed, all erosion, all transportation of material, is left to the tireless currents of the atmosphere. This is the domain of what geologists call aeolian processes, named after Aeolus, the Greek god of the winds. The wind acts like this planet's circulatory system, moving not water, but the very substance of the land itself. We can imagine it working on two scales. The larger grains of sand are too heavy to be lifted far, so they bounce and skitter across the surface in a process called saltation, a kind of low, flowing river of sand. But the finest particles, the dust, are lifted high into the atmosphere through suspension, where they can travel for thousands of kilometers, circling the globe on vast, predictable wind currents before slowly, gently, settling back to the ground. This ever-present dust would be fundamentally different from the dust of Earth. Our dust is rich with the debris of life, microscopic fragments of dried leaves, tiny pieces of pollen, fungal spores, flakes of our own skin. It is a testament to a world teeming with biology. The dust here would be purely mineral. It would be the pulverized remains of basaltic rock, the fine ash from ancient volcanoes, perhaps even tiny spherules of iron and nickel from the constant rain of micrometeorites from space. It is the ground-up bones of the planet, and nothing more. Its touch would be abrasive, its essence sterile. This mineral haze would have a profound effect on the colors of the sky, especially at dawn and dusk. We spoke of Rayleigh scattering, which makes the sky blue by scattering the shortest wavelengths of light. However, when the air is filled with larger particles like dust, another phenomenon called Mie scattering begins to dominate. These larger particles are less selective. They scatter all wavelengths of light more or less equally, but they are most effective at scattering light in the forward direction. Think of the difference between a fine mist and a thick fog. The mist might create a rainbow, separating colors, but the thick fog just makes everything a uniform, hazy white. As the sun sets on this dusty world, its light must travel through a much thicker slice of the atmosphere to reach our eyes. The blue light is scattered away from our line of sight, as it is on Earth, but the remaining red, orange, and yellow light is then picked up by the dust particles and scattered forward, creating not the vibrant, fiery spectacle of a cloud-painted sunset, but a more prolonged, subtle, and widespread glow. The entire sky might light up in soft shades of pink and orange, a diffuse luminescence that could linger long after the sun itself has vanished below the horizon, a gentle and beautiful farewell from a star shining through a dusty window. And as we stand there, breathing in this ancient, mineral air, we might reflect on what each grain of dust truly is. Each particle is a tiny piece of history, a miniature artifact. This one might be a fragment from a mountain that stood for 1 billion years before being worn down by the patient wind. That one might be a fleck of volcanic glass from an eruption in the planet's fiery youth. And another might be a speck of cosmic dust that travelled across the void for eons before finally settling here. The entire history of the world is not buried in its geology, but is instead floating in the air all around us, a library written in a language of stone. This ever-present dust, this symphony of particles carried by a wind that never ceases, must be doing more than just colouring the sky. It must be sculpting the very bones of the world. What do the mountains and valleys look like when they have been shaped only by the sand-blasting breath of the wind for an eternity? If water is the great carver of earth, the artist of canyons, river valleys, and gentle, rolling hills, what artist shapes a world without it? Here, the sculptor is the wind, and its medium is the endless supply of dust and sand we have just explored. The result is a landscape of impossible and breathtaking strangeness, an architecture of pure wind. On Earth, water erosion creates patterns that are familiar to us, patterns that speak of branching and gathering. A river system looks like the veins on a leaf, or the branches of a tree, a dendritic pattern where countless small tributaries flow together to form a mighty river, all of it cutting sharp, V-shaped valleys into the land. Water acts as a solvent, a chemical agent, and a powerful force, carrying away material in a way that is fractal and complex. But the artistry of wind is different. Wind is not a solvent, it is an abrasive. It is a celestial sandblaster, and it sculpts with a different logic, a logic of flow and streamlining. Imagine standing in a vast plain on this rainless world. Instead of hills, you might see enormous, elongated ridges of rock rising from the desert floor, all aligned in the same direction, like a fleet of colossal ships sailing through a sea of sand. These are called yardangs, and they are formed when the wind, armed with its payload of abrasive sand, scours away softer rock layers, leaving behind the harder, more resistant material. Over millions of years, these remnants are sculpted into impossibly smooth, aerodynamic forms, their prows facing into the prevailing wind, their bodies tapering gently behind them. They are monuments to the wind's relentless patience. Scattered among these giants, you might find smaller, more intricate sculptures. A single boulder, sitting alone on the plain, might be carved with sharp facets and polished to a sheen, its surface pitted and fluted by the ceaseless sandblasting. This is a ventifact, a stone shaped by the wind, each face a record of the direction from which the wind blew for a particular geologic age. And perhaps most beautifully, the wind would create arches of breathtaking delicacy, not by dissolving rock from above like water, but by scouring away the base of a rock fin, hollowing it out grain by grain, until only a fragile bridge of stone remains, a testament to what is taken away, a celebration of empty space. The very character of the wind itself would be different on this world. Earth's weather is a wonderfully complex and chaotic system, driven largely by the uneven heating of our planet and the immense thermal reservoir of our oceans. Water evaporates from the warm tropics, forming vast weather systems that are deflected and twisted by the planet's rotation, creating the unpredictable winds and storm fronts we know. But on a dry world, with no oceans to store and release heat, this primary engine of weather is absent. The atmosphere would respond much more directly and simply to the sun's energy. This would likely lead to global wind patterns that are far more stable, more powerful, and more predictable than Earth's. We can imagine immense, planet-circling jet streams, rivers of air that flow unimpeded for thousands of kilometers. The planet's rotation would still create the Coriolis effect, which on Earth deflects winds to the right in the northern hemisphere and to the left in the southern hemisphere. But in this simplified system, the effect might be even more pronounced, organizing the winds into massive, stable bands that circle the globe. The wind here is not a gentle breeze one day and a raging gale the next. It is a constant, a given, a force as reliable and as monolithic as the rising of the sun. It is a power that one must learn to live with, to build in harmony with, to respect as the single greatest agent of change. To look upon this landscape, this gallery of yardangs and ventifacts, is to meditate on the nature of patience. We think of wind as ethereal, as gentle, but here it has demonstrated that the softest and most persistent of forces can overcome the hardest of materials. A single grain of sand carried on the breeze does nothing to a mountain, but 1 trillion grains, striking the same face for 1 million years, can reduce that mountain to dust. It is a lesson in the power of gradual, incremental change, a story of time and abrasion written in the language of stone. This entire world is a monument to what has been taken away by the wind, a landscape defined by removal. But as we stand in the lee of a great, silent yardang, sheltered from the constant hiss of moving sand, our attention turns downward, to the ground beneath our feet. What of the surface itself, the skin of this world, that is constantly being stripped and reshaped? What does soil become when it is never blessed with the gift of water? Touch the ground on this silent planet. What do you feel? It is not the soft, yielding crumble of damp earth, nor the spongy texture of a forest floor rich with life. The surface here is a fine, loose powder, cold to the touch even under the relentless sun. If you scoop up a handful, it flows through your fingers like the sand in an hourglass, leaving behind a faint, dry residue. There is no earthy smell, no scent of decay or growth, only the sterile, mineral odor of pulverized rock. This is not soil, it is regolith, and the difference between the two is the difference between a corpse and a living being. Soil, as we know it on Earth, is one of the most complex and miraculous substances in the known universe. It is a living matrix, a bustling city of interacting components. It contains minerals from weathered rock, yes, but it is also teeming with organic matter from decaying plants and animals, and it is shot through with networks of air and water. Most importantly, it is alive. A single teaspoon of healthy soil can contain billions of microscopic organisms, bacteria, fungi, protozoa, all working in a complex web to break down matter and make nutrients available for plants. Soil is a dynamic, breathing entity. Regolith, however, is simply the blanket of loose, shattered rock and dust that covers the surface of a solid planet or moon. It is the product of purely physical processes. The expansion and contraction of rock from extreme temperature swings, the grinding action of the wind, and the pulverizing force of meteorite impacts over billions of years. It is a pantry stocked with all the raw mineral ingredients for life, but the chefs, the microbes, the water, the organic matter have never arrived. It is a collection of elements, but not a system. It is potential, but it is a potential that remains forever locked away. A key reason for this profound difference is the absence of chemical weathering. On Earth, water is often called the universal solvent for its incredible ability to dissolve more substances than any other liquid. As rain, slightly acidic from dissolved carbon dioxide, falls upon the land, it works its way into the cracks in rocks and begins a slow, inexorable process of chemical transformation. It dissolves minerals, breaking down complex crystalline structures and releasing the essential nutrients, the phosphorus, the potassium, the magnesium that plants need to grow. Without water, this fundamental process of liberation comes to a near complete stop. The chemical reactions that would take mere years or decades on Earth might require millions of years on this dry world. The nutrients remain bound tightly within the crystal lattice of the minerals. The regolith is a treasure chest, but the key to unlock it has been lost. The ground is rich, yet it offers no nourishment, and so the skin of this world is sterile, a deep and ancient layer of dust that holds the memory of every impact, every fracture, every moment of abrasion, but no memory of life. Yet, this does not mean the planet is entirely devoid of water. It is simply absent from the surface and the atmosphere. We must once again look deeper. It is entirely possible, even likely, that vast quantities of water could exist here, but locked away in a different form. Deep beneath the blanket of sterile regolith, where the sun's warmth cannot reach and the temperature remains permanently below freezing, there could be enormous layers of permafrost, ground that is eternally frozen solid. And deeper still, there may be vast aquifers of water ice, a hidden reservoir from a time long past when the planet was perhaps younger and wetter, now buried and protected from the harsh conditions on the surface. This is a world whose greatest treasure, its lifeblood, is buried deep in its own cold heart. Standing on this silent, dusty surface, we are overcome by this sense of profound and tragic potential. Everything needed for a vibrant, living world is here. The elements are in the regolith, the energy streams down from the sun, and the water may lie sleeping in the darkness below. It is a planet in a state of suspended animation, a garden waiting for a gardener who will never come. The ground beneath our feet is a sleeping giant, and its dreams are of a life it can never have. But if this water, this hidden promise, is locked away deep beneath the surface, could anything possibly reach it? Could life, in some desperate and tenacious form, find a way to drill down through the sterile dust and tap into this secret frozen heart? What if the silence of the surface was a lie? What if the desolate, wind-scoured plains and the sterile, dusty ground were merely a mask, a facade hiding the planet's deepest and most vital secret? What if the planet's lifeblood did not fall from the sky, but instead flowed in the profound and eternal darkness of the deep earth? Let us begin a journey downward, leaving the thin, sharp air and the relentless sun behind. We push down through the loose, powdery regolith, a journey through millennia of pulverized rock and cosmic dust. For meters, then hundreds of meters, the cold is absolute, a penetrating chill that speaks of a world without a blanket of humid air to hold in its warmth. But then, something begins to change. As we descend deeper, a subtle pressure begins to build around us, the immense weight of the rock above making itself known. And with that pressure comes a slow, gradual, and almost imperceptible rise in temperature. This is the planet's own inner fire, the geothermal gradient. Every planet, every moon of significant size, retains heat from its formation, a fiery core of molten rock and metal that slowly, over eons, radiates its warmth outward. It is a gentle, primordial heat, and as we sink deeper into the crust, we can feel its influence growing. The permafrost, the solidly frozen ground, gives way to rock that is merely cold, and then, finally, we reach a point where the temperature climbs past the freezing point of water. It is here, thousands of meters below the surface, that we find it. Not a vast open cavern, but a network of immense, interconnected fissures and pores within the rock, and they are filled with liquid. It is a hidden ocean, a planet-wide aquifer of water that has been trapped in the dark for billions of years. This water is not like the pure, fresh rain of Earth. It is a brine, thick with dissolved salts and minerals leached from the surrounding rock over countless ages. And this salinity, combined with the immense pressure from the miles of rock above, works a kind of magic. Both pressure and dissolved salts act as a natural antifreeze, lowering the temperature at which water freezes solid. It is the same principle we use when we salt our roads in the winter. The salt allows ice to melt even when the air temperature is below 0 degrees Celsius. Here, in the deep, the brine can remain liquid at temperatures that would turn pure water to solid ice. And so, a vast, dark, and secret ocean flows within the planet's crust. But could anything live here? In a place that has never known a single photon of sunlight, a place where the very concept of a sun is a meaningless abstraction. On Earth, nearly all life is sustained by the sun through photosynthesis, the miraculous process by which plants convert sunlight into chemical energy. This energy then flows up the food chain, feeding herbivores, who in turn feed carnivores. But in the eternal night of this subsurface ocean, photosynthesis is impossible. And yet, life might still find a way. We have a parallel in the deepest trenches of our own oceans, around volcanic vents that spew superheated, mineral-rich water from the Earth's mantle. In this total darkness, entire ecosystems thrive, built not on photosynthesis, but on a process called chemosynthesis. Here, instead of using sunlight, specialized microbes derive their energy from chemical reactions, metabolizing compounds like hydrogen sulfide, which smells of rotten eggs and is toxic to us, and turning that chemical energy into the energy of life. These microbes form the base of a completely independent food chain. This could be the engine of life on our rainless world. The planet's inner heat, the same heat that keeps the water liquid, could create hydrothermal vents on the floor of this subsurface sea. These vents would release a rich broth of chemicals and minerals from the planet's interior, a feast for chemosynthetic bacteria. These humble, single-celled organisms, performing their quiet chemistry in the dark, could be the foundation for an entire biosphere, a world of life completely hidden from the universe above. It is a profound thought that the most vibrant and essential part of this world is completely invisible, completely hidden from view. The silent, dusty surface tells a story of absence and sterility, but it is a misleading story. The planet's true heart beats in the darkness below, a quiet, chemical pulse that has perhaps sustained a lineage of life for billions of years. It reminds us that what we see on the surface, in any system, in any person, is rarely the whole and complete truth. The most important things are often those that lie hidden from sight. If life does exist in this profound darkness, fueled not by the light of a distant star but by the inner fire of the planet itself, what would it look like? What strange and wondrous forms would evolve in an eternal, sunless, high-pressure sea? Let us imagine the creatures of this deep, dark sea. We must first shed our terrestrial biases, our expectations shaped by a world of sunlight, air, and open spaces. The rules of life here are written by pressure, darkness, and chemistry. The ecosystem we are about to enter is one of hushed, slow-motion ballet, a world of strange and subtle wonders. As we drift through this silent, briny ocean, the first thing we might notice is the light. Not sunlight, of course, but a faint, ghostly, and internally generated glow. Great, fungi-like colonies might cling to the rock walls, their tendrils pulsing with a soft blue-green bioluminescence, a cold light produced by chemical reactions within their cells. These may be the primary producers, the chemosynthetic bacteria, living together in vast mats and films that coat the landscape, their glow a mere byproduct of their metabolism, turning the dark sea into a kind of starry night in reverse. Floating slowly through the water between these glowing formations are the herbivores of this world, the primary consumers. They are not cows or rabbits, but perhaps great, gelatinous, bell-shaped creatures, moving with a gentle, rhythmic pulse. They have no need for speed or agility. Their purpose is simply to drift and filter, drawing in the water and sifting out the microscopic, energy-rich microbes that form the base of this entire food chain. Their bodies might be translucent, their inner workings faintly visible, a slow and patient engine of consumption in the crushing dark. The logic of evolution in this eternal night would be mercilessly efficient. Senses that rely on light would be the first to go. Eyes, so central to our own perception of the world, would be a useless and biologically expensive luxury here. Over generations, they would shrink, fade, and disappear entirely, leaving behind only smooth, featureless faces. In their place, other senses would evolve to an incredible degree of sophistication. Sound, or rather the perception of vibration and pressure waves, would be paramount. Creatures might navigate and hunt using a form of biological sonar or echolocation, emitting clicks and calls and interpreting the echoes that bounce back from their surroundings. They would paint a picture of their world, not with light, but with sound. The sense of taste or smell, which for us is the detection of chemicals in the air, would here become the primary way of understanding the environment. Creatures would taste the water, following the faint chemical trails left by their prey, or sensing the plume of minerals from a distant hydrothermal vent, which for them would be an oasis of life, a restaurant in the desert. And then there are the predators. They would not be swift sharks or lunging crocodiles. Energy is too scarce here for such explosive movements. The hunters of the deep dark would be models of efficiency, paragons of patience. We can imagine a creature that mimics the shape of a rock, lying perfectly still on the seafloor for weeks, for months, waiting for a filter feeder to drift just a little too close. Its senses would be tuned to the faintest change in water pressure, the minute electrical field generated by another living thing's muscles. And when it strikes, it would be with a slow, deliberate, and inescapable motion, an unfurling of barbed tentacles, a quiet and final embrace. The very passage of time would feel different in this cold, energy-poor environment. Metabolism, the rate at which life processes energy, would be incredibly, profoundly slow. Growth would be measured in centuries. A creature's lifespan might not be counted in years or decades, but in millennia. They would be ancient beings, living their entire lives at a pace that would seem to us like a state of near-suspended animation. The drama of their lives, the hunt, the escape, the act of reproduction would unfold with the slowness of a growing crystal. And in this world of deep, unhurried time, we are forced to ponder the very definition of life. This ecosystem is utterly alien, its inhabitants bizarre beyond our wildest imaginings. And yet, it all follows the same fundamental rules that govern life on Earth. The acquisition and transfer of energy, the process of adaptation to an environment, the ancient dance of predator and prey. It is a powerful reminder that life is not a single form, but a principle, a process that can manifest in a staggering diversity of forms, all of them tenacious, all of them beautiful in their own way. This hidden life, this triumph of chemistry over darkness, is a world unto itself, but it is trapped. It is a kingdom confined to the deep. What about the surface? Could any organism, no matter how resilient, possibly brave that dry, irradiated, and unforgiving world above? On a world where nothing grows from the ground, could something grow within it? We have explored the deep, hidden ocean, a bastion of life in the eternal dark. But the surface remains, in our minds, a place of profound and desolate sterility. Yet, life's tenacity often exceeds the limits of our imagination. Let us return to the wind-scoured plains, under the pale, hazy sun, and look closer at the stones themselves. Pick up a rock. It feels cold and inert, its surface scoured smooth by millennia of wind-blown sand. It appears to be nothing more than a fragment of the planet's geology, a silent, dead thing. But what if we were to crack it open? With a sharp tap, the rock splits in two, and inside, just a few millimeters beneath the surface, we see it. A thin, dark line, a greenish or blackish layer running parallel to the rock's outer surface. It is a community of organisms, a microscopic forest living inside the stone. These are the stone eaters, or, as scientists on Earth call them, endoliths. The name comes from the Greek words endon, meaning within, and lithos, meaning rock. And they are not a product of science fiction. They are very real, found in the most extreme and inhospitable places on our own planet. In the searing heat of the Mojave Desert, in the frozen, wind-blasted dry valleys of Antarctica, a place often considered the closest terrestrial analogue to Mars, scientists have found these hidden worlds of life, thriving where nothing on the surface could possibly survive. Living inside a rock is a brilliant strategy for survival in a harsh environment. The rock itself becomes a fortress. Its solid structure provides a near-perfect shield against the damaging ultraviolet radiation that streams down from the sun, unfiltered by a thick, humid atmosphere. The stone also acts as a thermal buffer, a natural insulation against the violent swings in temperature between day and night. While the surface of the rock might bake at noon and freeze solid at midnight, a few millimeters inside, the temperature remains far more stable, a tiny cave of relative calm. But how do they get energy? And more importantly, how do they get water? The energy can come from the rock itself. Some of these incredibly resilient microbes are what we call lithotrophs, another wonderful Greek construction, meaning rock eater. They perform a kind of chemistry that is deeply alien to us surface dwellers. They do not eat plants or animals. They derive their energy from metabolizing inorganic minerals, effectively eating the iron, sulfur, or potassium that makes up their stony home. It is a slow and meager diet, but in a world of scarcity, it is enough. The question of water is more difficult. On a planet without rain, where the air is almost perfectly dry, where does the water for life come from? The answer is a testament to nature's subtlety. Even the driest atmosphere contains some water, a few molecules of H2O scattered here and there. During the coldest part of the night, when the temperature on the surface plummets, it might reach the dew point for this incredibly thin vapor. Water molecules could condense directly onto the crystalline surfaces of the minerals within the rock. For these endolithic communities, this is their only rain. They have evolved to absorb this minuscule amount of moisture, molecule by molecule, a slow and patient drink that must sustain them through the long, dry day. And so, within the very bones of this planet, a secret and resilient life persists. It is not a dramatic or glorious life. It is a life lived on a razor's edge, in the near darkness, on a diet of stone and a breath of frost. And yet, it lives. This challenges our very concept of what a home is. We think of a home as a structure we build upon the land, a shelter we create to protect us from the environment. But for these organisms, the environment itself is their home. The unyielding stone is not an obstacle to be overcome, but a sanctuary to be inhabited. They do not live on the world, they live in it. It is a profound and humbling thought that an entire biosphere could be hidden from sight, not deep underground, but just beneath the skin of every stone. But this life, this tenacious microbial film, is microscopic, clinging to the barest edge of existence. What would a larger, more complex organism, or even a more complex structure, look like if it had to find a way to exist on this desolate surface? What form would it take? If a tree cannot drink water from the soil, from what could it build its body? If life as we know it, based on the soft, flexible chemistry of carbon and water, is confined to the microscopic cracks in a rock, what else might exist on the vast, open plains? Let us imagine something different. Not life in the biological sense, with metabolism and reproduction, but a geological process that, over eons, creates a stunning imitation of it. We are standing now in a great, silent valley, and stretching before us to the horizon is a forest. But it is a forest of crystal. Towering structures, some as tall as the redwoods of earth, rise from the dusty ground. They are not made of wood and leaves, but of translucent, milky quartz, or perhaps deep purple amethyst, or gypsum as white as bone. They grow in beautiful, branching, fractal patterns, their crystalline limbs reaching for a sun they do not need. The light passes through them, not on them, and in the hazy air, it is splintered into 1,000 dull, shimmering rainbows. There is no sound of rustling leaves, only the high, thin whistle of the wind as it flows around these immense, silent forms. This is not a biological forest, it is a geological one. How could such a thing possibly form? It would be a process of exquisite slowness, driven by the planet's only remaining cycle, the extreme swing in temperature between day and night. The regolith, the dusty skin of this world, is rich in dissolved minerals, like silica or calcite. We learned that during the coldest part of the night, a tiny amount of atmospheric water vapor might condense on surfaces. Imagine if, over thousands of years, this minuscule amount of moisture was enough to create a highly concentrated, briny solution with the minerals in the ground. This process, where a solid absorbs moisture from the air to become a liquid, is called deliquescence. Now, as the sun rises and the temperature climbs, this tiny droplet of mineral-rich water would begin to evaporate. But because the solution is so saturated, as the water leaves, the mineral that was dissolved in it has nowhere to go. It must precipitate out, forming a microscopic crystal. Now, repeat that process, every single night, for 1,000,000 years. Each night, a tiny bit more moisture is drawn from the air. Each day, that moisture evaporates, leaving behind another infinitesimal layer of crystal, adding to the structure that was formed the day before. Over geological time, these structures would grow, molecule by molecule, following the inherent geometric logic of crystal formation, branching and rising into the thin air, creating a forest of stone. The chemistry of this world might also favor different building blocks. While life on Earth is based on the incredible versatility of the carbon atom, its sister element on the periodic table, silicon, shares some of that versatility. Silicon can form long chains and complex structures, and it is the basis of all the rocks and sands of this world. This crystal forest could be seen as a kind of alternative, silicon-based structural expression, a form that mimics the complexity of life using the planet's most abundant materials. And these strange, silent trees would not be static. They would be locked in a slow-motion dance with the wind. The same aeolian forces that carve the yardangs and shape the ventifacts would be at work here too. The constant, abrasive wind would etch the surfaces of the crystals, polishing some faces while pitting others, perhaps carving delicate flutes and arches into their massive trunks. It would be a forest that is simultaneously growing and being eroded, a dynamic equilibrium between slow addition and slow subtraction, a sculpture being continuously reworked by its environment. Standing in this silent, crystal valley, we are forced to ponder the blurry line between what is alive and what is not. These crystal trees grow. They possess an intricate and beautiful structure. They respond to their environment, and they change over time. They do not metabolize. They do not reproduce in a biological sense. But do they need to in order to be considered magnificent? Perhaps they represent a different kind of order, a different way for a planet to express its complexity, a quiet, contemplative beauty that exists for its own sake. The world we have explored so far has been one of deep silence, punctuated only by the hiss of wind and the crack of cooling stone. It is a world we have primarily seen and felt, but is a world without rustling leaves or flowing rivers, without the pitter-patter of rain, truly silent. Or does it have a sound that is uniquely its own? Close your eyes and listen. What do you hear in a world without a single drop of water? Our first instinct is to imagine a profound silence, an absolute and empty void of sound. But that is not quite right. The absence of water does not mean the absence of all noise. It simply means the world speaks in a different language, a language of stone and wind and immense, slow temperature changes. The dominant sound, the one that forms the constant background hum of this world, is the high, thin whistle of the wind. It is not the deep, rustling sound of wind moving through a forest of leaves, a sound that is soft and full of life. This is a sharper, purer sound, the sound of thin air flowing over the smooth, carved surfaces of yardangs and the sharp edges of ventifacts. It is a lonely and ancient song. Beneath this whistle, you can hear the soft, percussive hiss of moving sand, a sound like a billion tiny whispers, the constant saltation of grains across the desert floor. And then there are the sudden, sharper sounds. A sharp crack, like a rifle shot in the distance, echoes across the plain as a rock, stressed by the enormous temperature swing from day to night, finally fractures. In the deep cold of the evening, you might hear a low, resonant groaning from the rock fields, a sound that is almost organic, like a great beast stirring in its sleep. It is the sound of the planet itself sighing, its stony bones contracting in the cold. What is profoundly and noticeably absent is the entire chorus of sounds that water makes on our world. There is no gentle gurgle of a hidden spring, no rush of a flowing river, no crash of waves upon a shore, and most of all, there is no soft, rhythmic patter of rain on a roof, no thunderous downpour of a summer storm. The vocabulary of water is gone, and with it, the symphony of life that it orchestrates. There are no buzzing insects, no chirping birds, no croaking frogs, no rustling of creatures through damp undergrowth. The silence we perceive here is not an absence of sound, but an absence of the familiar sounds of a waterborne biology. The very physics of sound would be different here. Sound travels as a wave, a vibration moving through a medium. The properties of that medium dictate how the sound behaves. On Earth, our relatively thick, humid atmosphere acts as a kind of acoustic blanket. It muffles sharp sounds, absorbs higher frequencies, and allows noises to blend into a rich and complex soundscape. It is like a concert hall filled with heavy velvet curtains and plush carpets, which absorb echoes and soften the notes. The thin, dry atmosphere of our rainless world would be the opposite. It would be an acoustically harsh environment, like a concert hall made of bare stone and glass. With fewer molecules to carry the vibration, and no water vapor to absorb the energy, sounds would not travel as far, but the sounds you could hear would be incredibly sharp and clear. Every crack, every hiss, every whistle would be distinct, with no acoustic fog to blur them together. This phenomenon of rocks cracking and groaning is a direct result of the lack of a water-moderated climate. It's a process called thermal stress. During the day, the unfiltered sun heats the surface of a rock, causing it to expand. At night, without a humid atmosphere to trap the heat, the temperature plummets, and the rock's surface contracts rapidly. This constant cycle of expansion and contraction, day after day for millions of years, creates immense stress within the rock's structure, eventually causing it to fracture and break apart. The sounds we are hearing are the growing pains of the planet's geology, a process of slow, relentless decay made audible. As we sit and listen to this alien symphony of wind and stone, we might reflect on how deeply our own sense of peace is connected to the sounds of water. The gentle lapping of a lake, the steady rhythm of a light rain, the distant roar of the ocean. These are sounds we find almost universally soothing. They speak to something ancient within us, a deep, instinctual knowledge that the presence of water means the presence of life. Could we learn to find a different kind of peace here? Could we attune our ears to the hiss of the sand and the song of the wind, and find in them a new kind of lullaby, a meditation on permanence and deep geological time? This world, shaped so profoundly by its atmospheric physics, by the way it carries light and sound, would be just as shaped by the very makeup of that atmosphere. This thin, dry air, which whistles and sings its lonely song, impacts not only the senses of sound and sight, but would fundamentally alter the chemistry of the very air we might breathe. What would that air be made of when it is never, ever washed clean? Breathe in the air of this rainless world. What fills your lungs? We already know it is dry and thin, and tastes of mineral dust. But there is another quality to it, a quality of profound stillness, of permanence. It feels heavy, ancient, and unchanging. On Earth, the atmosphere is in a constant state of renewal. A volcanic eruption can fill the air with ash and sulfur, but over weeks and months, the rains will come and wash it clean. The dust from a storm in the Sahara can travel across the Atlantic, but it will eventually be pulled down into the ocean. The air is cleansed, forgiven its impurities, and given a fresh start. Here, there is no forgiveness. An atmosphere that is never washed becomes a kind of museum, a library of every event that has ever occurred. Imagine a great volcano erupting, spewing billions of tons of sulfur dioxide and fine ash into the sky. Without rain to scrub these compounds out, they would simply stay there, suspended in the thin air. They would spread on the global winds, forming a hazy, yellowish veil that could persist not for years, but for centuries, for millennia. A permanent scar on the sky from a wound inflicted in the deep past. Every major meteorite impact would do the same, throwing up a cloud of pulverized rock that would join the permanent collection of atmospheric dust. The air would become a stratified record of geological history, with layers of different compositions hanging silently in the sky for eons. The scientific term for this cleansing process on Earth is atmospheric deposition, and it is a cornerstone of our planet's health. Raindrops are not made of pure water. They require a tiny seed, a condensation nucleus, to form around. This can be a speck of sea salt, a grain of pollen, or, crucially, a particle of dust or pollution. The rain effectively gathers up the impurities in the air and brings them down to the ground, a process known as wet deposition. Without this constant, planet-wide shower, the atmosphere of our dry world would be in a state of perpetual accumulation. All the aerosols, all the particulates, all the outgassing from the planet's interior would simply build up over time. And this would lead to another, more familiar phenomenon, but on a terrifying and planetary scale. Photochemical smog. We know of smog as the brownish haze that hangs over our big cities, especially on hot, sunny days. It is formed when sunlight acts upon pollutants in the air, particularly nitrogen oxides and volatile organic compounds, causing them to undergo a series of chemical reactions. The result is a thick, unhealthy, and visibility-reducing haze. Now, imagine this process on our rainless world. The atmosphere is already thick with unwashed chemicals, sulfur compounds from volcanoes, nitrogen compounds perhaps created by lightning in the thin air. The sunlight is intense and unfiltered. This is the perfect recipe for a permanent, global, photochemical smog. The sun would constantly bake this stagnant, chemical-rich air, creating a complex and perhaps toxic atmospheric brew. The sky might lose its deep, pure blue, taking on a perpetual brownish or yellowish tint. The air would have a sharp, chemical tang, the smell of reactions that are never washed away. And so, we find ourselves in an atmosphere that is not only dry, but in some ways, deeply unclean. It is a sky that holds on to everything and lets nothing go. This leads to a rather philosophical reflection on the nature of renewal. Rain on Earth is more than just a part of the water cycle. It is a metaphor for a fresh start, for the washing away of the old to make way for the new. We speak of our troubles being washed away, of a cleansing cry. Our world is one that is constantly being reborn, its slate wiped clean. An unwashed atmosphere is a sky that cannot forget. It is a sky that bears the memory of every catastrophe, every eruption, every impact. Its composition is a testament to its entire, long, and arduous history. It is a world without absolution. If an intelligent species were to evolve here, to breathe this ancient, chemical air, and to look up at this hazy, unchanging sky, what kind of bodies would they have? What strange and wonderful form would a creature native to such a world be forced to take? Let us imagine the inhabitants. What would it mean to be born of a world where water is the most precious and rarest of jewels? What kind of body, what kind of physiology would evolution sculpt in response to such an unyielding and arid environment? The creature that stands before us in our mind's eye is a being of profound efficiency, a master of conservation. It would not have our soft, permeable skin, which is a luxury born of a water-rich world. Instead, its body might be covered in a hard, chitinous exoskeleton, much like an insect on Earth. Or perhaps something even more exotic, a casing infused with silicate minerals, a kind of living stone. This armor would be nearly impervious to the dry air, its surface polished by the constant wind, a perfect seal against the relentless theft of its internal moisture. Its movements are slow, deliberate, and graceful. Every motion is measured, every expenditure of energy carefully considered, for to waste energy is to waste the water that is metabolized to produce it. Life here would not be a sprint, it would be a marathon of unimaginable length, and the key to victory is endurance. How would such a creature breathe in the thin, dusty, and chemically laden air without losing its precious internal water? It would not have exposed, moist lungs like our own. Instead, it might have a complex internal labyrinth, a series of spiracles or openings in its exoskeleton, leading to a branching network of tubes. As it inhales, the dry air passes over a series of moist membranes, allowing for gas exchange. But as it exhales, the air is forced back through a different part of the labyrinth, a series of cooled, convoluted passages that act as a natural condenser. The moisture from its breath would precipitate onto these surfaces and be reabsorbed into its body, a closed-loop system of such efficiency that almost no water is ever lost to the outside world. This is a strategy we see in miniature on Earth. The kangaroo rat of the American deserts has a similarly complex nasal passage that allows it to survive without ever drinking liquid water. Our dry being would simply be the ultimate expression of this principle. To fuel its slow metabolism, it must take in energy. Perhaps it is a lithotroph, like the endoliths we discovered, but on a macro scale, a creature that can slowly grind and digest mineral-rich rocks. Or perhaps it is a kind of photosynthesizer, but instead of broad, delicate leaves, it might have crystalline plates on its back, using the harsh sunlight in a form of solid-state photosynthesis that requires very little water. And what of its internal chemistry? We are so accustomed to life being based on water as its primary solvent, but in such an extreme environment, a different solution might be necessary. Perhaps this creature's biology is not water-based at all. Its cells might be filled with a different liquid, one with a much lower freezing point and a much higher boiling point, something that is less prone to evaporation. Perhaps it uses a form of ammonia, or a complex hydrocarbon, or a lipid-based fluid. This would represent a truly alien biochemistry, a different path for life altogether, with different proteins, different enzymes, a completely separate genesis. This being would perceive the world through senses honed by the necessities of its environment. Its eyes, if it had them, would be deeply recessed, protected by multiple layers of transparent, nictitating membranes that would constantly sweep them clean of dust. But sight might not be its primary sense. In a world of shimmering dust, haze, and harsh, glaring light, vision could be unreliable. Instead, it might be its sense of touch, or rather, its connection to the ground itself, that is most acute. Its feet might be broad and sensitive, able to detect the faintest seismic vibrations traveling through the planet's crust. The distant footfall of another creature, the subtle shift of a sand dune, or perhaps even the vibration that signals a subterranean pocket of frozen ice. It would listen to the world with its feet, reading the story of the land through the language of vibration. To look upon this creature is to look upon a mirror, one that reflects back to us our own profound dependence on water. We are, each of us, a walking ocean, a small piece of the primordial sea encased in a thin membrane of skin. Our cells are bathed in a saline solution. Our thoughts are generated by electrical signals in a watery brain. We are beings of the flood, and every aspect of our biology is a love letter to the abundance of water. This dry being, in its beautiful and austere efficiency, shows us that this is not the only way to be. It forces us to recognize how deeply our environment has shaped not only our bodies, but our very definition of what it means to be alive. A body shaped by this world is one thing, but what of the mind within? How would a consciousness born under an unchanging, cloudless sky think and feel? How do you dream when there are no clouds to watch? How does a mind form its sense of self, its understanding of the world, when the world itself is one of relentless predictability, of stark, unchanging cycles? Let us try to imagine the consciousness of the dry being we have just envisioned. Its thoughts would likely not be the restless, chaotic, and associative streams that we are used to. Our own minds are shaped by our environment, a world of constant, unpredictable change, of shifting weather and seasons. We gaze at the clouds and see faces, animals, stories. This act of pareidolia, of finding patterns in randomness, is a cornerstone of our creativity. But a mind born under a flawless, unbroken blue has no such canvas for its imagination. Its thought processes might be more linear, more logical, more geological in their pace, less like a bubbling stream and more like a growing crystal. The very language this being would use to construct its thoughts would be fundamentally different from our own, for it would be missing an entire universe of metaphors that we take for granted. So much of our abstract thought, of our emotional expression, is rooted in the language of water and weather. This is a concept in cognitive science known as the conceptual metaphor. We understand difficult abstract ideas by mapping them onto simple, physical experiences. We feel down when we are sad. Our spirits are lifted when we are happy. And a vast portion of this metaphorical landscape is drawn from water. We speak of a storm of anger, a wave of grief, a flood of relief. An idea can be muddy or crystal clear. We can be drowning in sorrow or frozen with fear. Our emotions ebb and flow like the tides. A person's thoughts can be shallow, or they can have hidden depths. An entire lifetime of experiences and feelings, for us, is articulated through the language of a wet world. This dry being would have none of these. Its language of emotion and thought would have to be built from a different set of raw materials. The hardness of stone, the sharpness of the wind, the slow cycle of light and dark, the vastness of the stars. What would it mean to love in a language that cannot speak of a torrent of passion? How would it express sadness without the metaphor of tears or rain? Its internal world would be just as rich as our own, but its texture, its flavor, would be utterly alien to us. Its perception of time might also be profoundly altered. Our sense of time is marked and measured by the constant change of weather. We remember a sunny afternoon, a snowy winter, a rainy morning. These atmospheric changes break up the monolithic march of days into unique, memorable moments. Without weather, the only markers of time are the stark and utterly predictable cycles of the sun and the stars. Day follows night follows day, in a rhythm that is never, ever interrupted. Time might feel slower, more immense, its passage measured not in days or seasons, but in the slow erosion of a rock face, or the alignment of planets in the unchanging sky. This would likely foster a psychology of immense patience, a culture built around long-term thinking. When change is slow and predictable, there is no rush. This would be a mind that is comfortable with waiting, a mind that understands deep time not as an abstract concept, but as a lived reality. This psychology would be further shaped by the central, organizing principle of its existence: the absolute scarcity of water. A culture born from such a world would likely have conservation not just as a policy, but as its most sacred religious and ethical principle. The idea of waste would be the greatest sin. Every action would be weighed against its cost in moisture. This could create a society that is highly communal, deeply cooperative, and perhaps even rigid in its social structures, all organized around the shared goal of preserving the single resource that matters. As we imagine this mind, we realize how much of our own culture, our art, and our philosophy is a response to the sky. The moody, dramatic landscapes of the painter Turner are all about the beautiful violence of a stormy sky. The poems of Wordsworth are filled with wandering clouds. The central metaphor of King Lear's madness is a raging tempest on a heath. An entire dimension of our creative and emotional expression is born from the simple fact that our sky is dynamic and alive. The consciousness of this dry being would be a thing of austere beauty, like the landscape that shaped it. It would be a mind of quiet contemplation, of deep patience, and of an intimate connection to the stone and stars. Its stories and its art would be as strange and as wonderful to us as our stories of floods and storms would be to it. Their culture would be so different, built around concepts we can barely imagine. What would their myths be? What would they worship? In a world where no god speaks from a thundercloud, on a world without a water cycle, what cycle would form the basis of all myths? On Earth, the stories we tell ourselves, the deep, foundational myths that explain our place in the cosmos, are inextricably tied to the cycles of water and the life that it brings. We have countless flood myths, stories of a world washed clean by divine displeasure. We have gods of the sea and spirits of the river. But most profoundly, our sense of time, of death and rebirth is mirrored in the seasons, a cycle driven by the sun, yes, but expressed through the presence or absence of life-giving rain. The spring thaw, the summer thunderstorms, the autumn mists, the winter snow. This is the rhythm that underpins our stories of gods who die and are reborn, like Persephone returning from the underworld to bring life back to the land. But on our dry world, there is no Persephone. There is no cycle of death and rebirth tied to the seasons of water. And so, the inhabitants would find their metaphors for eternity and change in the only cycles available to them: the cycles of geology and the cycles of the heavens. Their creation myths would not speak of a world born from a primordial ocean. Instead, they might tell of a great cosmic wind, a divine breath that gathered the first dust into sentient beings. Or perhaps they would believe that life did not descend from the sky, but emerged from the deep earth, from the geothermally heated heart of the planet, a mythology of the underworld not as a place of death, but as the exclusive cradle of all life. The central cycle of their philosophy might be the great cycle of stone. They would see the mountains, over millions of years, being slowly, patiently worn down into sand and dust by the wind. And they would see how that same dust, in the deep earth, is compressed by immense pressure back into new stone, into slate and marble. Their concept of reincarnation would not be one of spirits returning to new bodies, but of the very substance of the world being ground down and then reformed. To them, A mountain would not be a permanent feature, but a single, slow-motion life form, and the dust would be its spirit, waiting to be reborn as new rock. With a sky that is forever clear, their connection to the stars would be absolute. The heavens would not be a mysterious place, occasionally glimpsed between clouds. It would be a constant, overwhelming presence, a perfectly reliable celestial clock. Their mythology would almost certainly become an astrotheology. Their greatest gods would be the sun, the distant, silent moons, and the planets that wander with such mathematical grace among the fixed stars. Their priests would be astronomers, their temples, observatories. Every celestial event, the transit of a planet, the arrival of a comet, the explosion of a distant supernova, would be a divine message, an omen to be carefully interpreted. The sky would be their sacred text, written in a language of light and gravity, and there is a sensory element of our own mythology that would be entirely absent from theirs. On Earth, when rain falls after a long dry spell, the air is filled with a unique, beloved scent called petrichor. It is the smell of the earth coming back to life. This scent is deeply reassuring to us, likely because for our distant ancestors, the smell of coming rain was the ultimate promise of survival. It is the scent of hope. For these dry beings, there would be no such myth, no concept of a sweet, life-giving perfume sent from the heavens. The sky would be a source of light and heat, a canvas for their star gods, but it would never offer a blessing that they could smell, a scent that promised renewal. Their divine would be a thing of sight and intellect, not of earthy, sensory relief. And in this, we find a beautiful and profound truth. No matter the environment, no matter how alien the conditions, it seems a fundamental need of intelligent consciousness to weave stories, to create meaning from the patterns of the world. The fundamental questions are always the same. Where did we come from? Why are we here? Where are we going? The beings of our rainless world would ask these same questions, but their answers would not be written in water, but in the slow, patient language of dust and stars. These stories, however, are of a hypothetical world, a product of our own imagination. But does such a place, a world that has lost its water, truly exist somewhere out there, among the countless stars in that clear, dark sky? We do not have to imagine a planet without rain. We have one next door. For the entirety of our journey so far, we have been wandering through a world of speculation. But now, let us ground ourselves in a real place. A world of rust-coloured dust and silent, frozen canyons that has fascinated humanity for centuries. Let us turn our gaze to our neighbour in the solar system, the fourth planet from the Sun, Mars. If we could stand on the surface of Mars today, perhaps beside the Perseverance rover in Jezero crater, the scene would be uncannily familiar to the world we have just been imagining. The ground is a vast expanse of reddish-brown regolith, littered with rocks that have been scoured and shaped by a wind that never ceases. The sky is not blue, but a thin, pale, pinkish tan, its colour a result of the fine dust that is permanently suspended within its wispy atmosphere. The sun is a small, sharp disk, its light feeling distant and cold. There are no clouds, there is no rain, and the only sound is the whistle of the thin wind and the gentle whir of the rover's instruments. It is a world of silent, profound, and lonely beauty. But the story of Mars is even more poignant than that of our hypothetical world, because Mars was not always this way. It is not a planet that never knew rain, but a planet that had it, and then lost it. The evidence is now overwhelming, carved into the very face of the planet. Orbiters have mapped its surface in stunning detail, revealing features that are unmistakably the remnants of ancient rivers, vast lakes, and perhaps even a shallow ocean in its northern hemisphere. The very place where the Perseverance rover is exploring, Jezero crater, was chosen because it is the site of a perfectly preserved river delta. Billions of years ago, a river flowed into a crater lake here, depositing sediment in a familiar fan shape, exactly as the Mississippi River does when it flows into the Gulf of Mexico. The rover has analyzed the rocks of this ancient lake bed and found minerals like clays and carbonates, which, on Earth, only form in the presence of liquid water over long periods. Mars, in its youth, was a warmer, wetter world, with a thicker atmosphere and a functioning water cycle. It had clouds, and it had rain. So what happened? Where did all the water go? The answer is a story of planetary misfortune. A planet's ability to hold onto its atmosphere and its water is dependent on two key things: its size, which determines its gravity, and the presence of a global magnetic field. Mars is much smaller than Earth, with only about 1/10 of its mass, so its gravitational pull is weaker. But the truly catastrophic event in Mars's history was the death of its magnetic field. On Earth, our liquid iron core spins, creating a powerful magnetic field that surrounds our planet like an invisible shield, deflecting the most harmful, high-energy particles that stream constantly from the sun. This stream is called the solar wind. Early in its history, Mars had a molten core and a protective magnetic field of its own. But because it is smaller, its core cooled and solidified much faster than Earth's. About 4 billion years ago, its magnetic field died. Without this shield, the solar wind slammed directly into the Martian atmosphere, and over hundreds of millions of years, it stripped the air away, molecule by molecule, blowing it out into space. As the atmosphere thinned, the air pressure at the surface dropped precipitously. Eventually, it fell below a critical point called the triple point of water, the pressure below which liquid water can no longer exist. Any liquid water on the surface would simply boil away into the thin air, and this vapor would then be stripped away into space by the solar wind. The rain stopped, the rivers ran dry, the lakes evaporated, and Mars became the frozen, arid desert we see today. But not all the water was lost. A great deal of it is still there, locked away as ice in the brilliant white polar caps, and buried in vast sheets beneath the dusty surface, a hidden reservoir that future human explorers might one day tap into. And so, Mars tells us a different story. It is not a tale of what could never be, but a tragic elegy of what was lost. Its silence is not the pristine quiet of a world that never knew life's potential, but the haunting silence of a tomb, a ghost of a once-living world that now whispers to us of the fragility of planetary habitability. Mars is one example, a close and intimate one. But as we lift our gaze and look further, out to the countless stars in the deep night, do we see other worlds that might be trapped in this same rainless state? Let us lift our gaze from our own solar system and look to the true, deep. For as long as we have been human, we have looked up at the night sky and seen points of light, the steady glow of our planetary neighbours and the distant twinkle of the stars. We once thought they were merely lights, but we now know that each one of those twinkling stars is a sun, much like our own, and that the vast majority of them are orbited by planets. We call them exoplanets, and in the last few decades, we have found thousands of them. Our galaxy is a gallery of worlds, a cosmic museum filled with more planets than there are stars, a number so vast it defies easy comprehension. Let us take a gentle journey through this gallery. Here is a planet of a type we call a hot Jupiter, a gas giant larger than our own Jupiter, orbiting so perilously close to its parent star that its year lasts only a few Earth days. Its atmosphere is scorched to thousands of degrees. Its clouds are made not of water, but of vaporized iron and silicate minerals that rain molten glass. This world knows no gentle precipitation, only a searing, eternal inferno. Over here, we see a world that is tidally locked to its star, the same way our moon is locked to the Earth, with one side forever facing its sun. The sun-facing side is a permanent, blasted desert, its rock melted into a sea of lava. The far side is a realm of absolute darkness and unimaginable cold, a landscape encased in frozen nitrogen. And in the twilight zone between these two extremes, a perpetual, howling wind rages, a storm that has no beginning and no end. We drift further and find a super-Earth, a rocky world several times more massive than our own. Its immense gravity has allowed it to hold onto a thick, crushing atmosphere of hydrogen and helium. The pressure at its surface is so great that it would instantly flatten any vessel we could send, a pressure that transforms the very nature of matter. There is no clear distinction here between gas and liquid, only a deep, dense, soupy ocean of supercritical fluid. The vast, overwhelming majority of worlds in this gallery are like these. extreme, inhospitable, and utterly without the possibility of liquid water or gentle rain. The conditions for rain are, it turns out, astonishingly precise. Astronomers speak of a concept called the habitable zone, or more poetically, the Goldilocks zone. It is the narrow orbital band around a star where the temperature is not too hot and not too cold, but just right for liquid water to exist on a planet's surface. If a planet is too close, its oceans will boil away, creating a runaway greenhouse effect that thickens the atmosphere and bakes the world, like Venus. If it is too far, its water will freeze into a permanent, global sheet of ice. But even being in the habitable zone is no guarantee. A planet must also be the right size, massive enough to hold on to its atmosphere through gravity, and it must have the right geological and chemical ingredients. How do we know what these distant worlds are like? We study them by watching them pass in front of their stars. As an exoplanet makes this transit, the star's light dims by a tiny, almost imperceptible amount. But just as the planet begins or ends its passage, the starlight filters through its thin atmospheric skin. By analyzing this light with a tool called a spectroscope, astronomers can see a kind of chemical barcode. Certain colors of light will be missing, absorbed by the gases in the planet's atmosphere. This barcode can tell us if there is methane or carbon dioxide, or, most excitingly, the telltale signature of water vapor. And so we find that the rainless worlds we have been imagining are not the exception in the universe. They are the rule. There are worlds that were born too small, their gravity too weak to ever hold an atmosphere. There are rogue planets, thrown out of their solar systems during their chaotic formation, now wandering the cold, interstellar, dark, frozen solid. And there are worlds that once had water, but like Mars, lost their magnetic fields and had their atmospheres scoured away by their sun's stellar wind. It is a cosmic lottery, and the winning ticket that allows for a stable, temperate, rainy world is fantastically rare. Our planet, it seems, is not a typical example of a world, but a stunning and precious exception. After journeying across these countless, alien, and inhospitable worlds, the mind naturally begins to drift back home, back to the familiar blue and white marble that we know. What is it, truly, about the simple, humble fall of rain that we have lost on this long journey, and that makes our world so miraculous? Let us return home and consider a single raindrop. After our journey through the vast, sterile landscapes of dry worlds and the fiery chaos of distant exoplanets, let us now focus our attention on something small, familiar, and perfect. Imagine one single drop of water forming in the soft, grey belly of a cloud. It begins its existence as a microscopic droplet, so tiny and light that it can remain suspended for days on the gentle updrafts of the air. But it is not alone. It is one of billions, all of them slowly, gently colliding and merging, growing larger and heavier. This process of coming together is only possible because each droplet has a secret at its heart. A raindrop cannot form from pure water vapor alone. It needs a seed, a microscopic imperfection to cling to. This is called a condensation nucleus, and it can be a tiny speck of dust from a distant desert, a grain of sea salt lifted from a breaking wave, or even a particle of pollen from a flower. In this, there is a beautiful paradox. The purity of the rain is only made possible by the impurity of the air. Every cleansing shower is born from a particle of dust. Our single raindrop, now heavy enough to overcome the updrafts, begins its long, silent fall toward the earth. We have a romantic image of a falling raindrop as being shaped like a teardrop, a sphere with a pointed tail. But this is a myth. The reality is shaped by the physics of its journey. When it is very small, the powerful force of surface tension holds it in a near-perfect sphere, the most efficient and stable shape for a liquid to assume. As it falls and grows larger, it speeds up, and the pressure of the air pushing up against its base begins to flatten it. A large, falling raindrop is not shaped like a teardrop, but more like a small, round hamburger bun, or perhaps a kidney bean, its bottom flattened and its top domed. It does not fall unimpeded. If it did, after a journey of thousands of feet, it would strike the ground with the speed of a bullet. Instead, as its speed increases, so does the force of air resistance pushing up against it. Eventually, it reaches a point of perfect balance, a point called terminal velocity, where the downward pull of gravity is exactly cancelled out by the upward push of the air. At this speed, it no longer accelerates, but falls at a constant, gentle rate, a speed that allows it to nourish the ground, not destroy it. And what holds this little parcel of water together on its journey? It is a quiet and immensely powerful force called surface tension. Water molecules have a natural attraction to one another, a result of their polarity. They are like tiny magnets, with a positive and a negative end. This causes them to cling together with remarkable strength, a phenomenon known as cohesion. At the surface of the drop, where the water meets the air, there are no water molecules above to pull on, so the surface molecules are pulled inward by the ones below and beside them, creating a kind of tight, elastic skin. This is the same force that allows a water strider to skate across the surface of a pond, its feet held up by this invisible, flexible membrane. As our raindrop nears the ground, its tiny, spherical surface acts as a lens, capturing and reflecting a miniature, upside-down image of the world. It is about to meet a blurry vision of green trees and a grey sky. And then, with a soft patter, its journey ends, as it merges with a leaf, a blade of grass, or the surface of a quiet puddle. In this one, simple, falling droplet, we can see a universe of physics at play. It is a perfect little capsule of gravity, fluid dynamics, air resistance, and molecular chemistry. The fundamental forces that shape galaxies and ignite stars are the same forces that shape this humble drop of water and guide it on its gentle descent. It is a meditation on the elegant and universal nature of physical law, a reminder that the magnificent and the mundane are governed by the same perfect rules. We have felt the perfection of a single drop. But what happens when billions of them fall together, blessing the land? What is the chemistry of that first, wonderful scent of rain? Do you know that scent? The smell of the earth after a long dry spell. When the first rains finally arrive, it is one of the most beloved and universally recognized fragrances in the world, yet it is difficult to describe. It is more than just the smell of wet dirt. It is a complex perfume, a mix of the clean, sharp scent of the air itself, the deep, rich aroma of the soil, and something else, something fresh and green and alive. It is a scent that feels ancient, nostalgic, and deeply, profoundly reassuring. It is the scent of the earth, sighing in relief. This smell has a name, coined by two Australian scientists in the 1960s. They called it petrichor, a combination of the Greek words petra, meaning stone, and ichor, the golden fluid that was said to flow in the veins of the gods. The golden blood of the stone, and the science behind this divine scent is as beautiful as the fragrance itself. A story told in 3 distinct chemical chapters. The first part of the scent often arrives just before the rain itself, carried on the gust front of the approaching storm. It is a sharp, clean, and slightly metallic smell, the smell we often associate with lightning. This is the scent of ozone. Ozone is a molecule made of 3 oxygen atoms, O3, a highly reactive cousin to the stable, O2 molecule that we breathe. The immense energy of a lightning bolt can tear apart the stable nitrogen and oxygen molecules in the air, which then reform into various compounds, including ozone. This newly created ozone is carried down to the ground by the storm's downdrafts, announcing the coming rain with its distinctive, clean fragrance. Then, as the first drops begin to fall, the main symphony begins. The rich, earthy, and unmistakable heart of petrichor comes from a compound called geosmin. Geosmin is an organic molecule produced by a specific type of bacteria that lives in the soil, called streptomyces. These bacteria are abundant and essential for the health of the soil, but they are most active when conditions are damp and cool. During a dry spell, they produce more of this geosmin compound. The human nose is exquisitely, almost unbelievably, sensitive to geosmin. We can detect it in the air, at concentrations as low as a few parts per trillion. To put that in perspective, if you were to take one drop of geosmin and disperse it into a large, Olympic-sized swimming pool, you would still be able to smell it. Our sensitivity to this compound is far greater than a shark's sensitivity to blood in the water. The final notes in this perfume come from the plants. During long periods of drought, many plants secrete certain oils that accumulate in the soil and on the surface of dry rocks. These oils are a kind of defense mechanism, thought to inhibit seed germination and slow down plant growth, thereby helping the plants to conserve resources in a time of scarcity. So we have these three ingredients: the ozone from the air, the geosmin from the soil bacteria, and the oils from the plants, all waiting patiently for the rain. But how does the rain release them into the air for us to smell? The mechanism is a delightful piece of physics. When a raindrop strikes a porous surface like dry soil, it traps tiny pockets of air beneath it. These air bubbles, now inside the raindrop, are less dense than the water around them, so they shoot upwards to the top of the drop. As they burst through the surface, they launch a fine spray of microscopic water droplets into the air, a phenomenon known as an aerosol. These tiny aerosol jets carry the geosmin and the plant oils with them, releasing the full, beautiful fragrance of petrichor into the air. And so we find ourselves reflecting on why this particular scent has such a powerful and positive effect on us. Why does it feel so good? Evolutionary psychologists believe the answer is buried deep in our ancestral past. For our early human ancestors, a dry spell meant hardship. The plants would wither, the game animals would move on, and survival would become a daily struggle. The coming of rain was the most important event in their world, and the scent that preceded it, this beautiful petrichor, was the ultimate signal of hope. It was the promise of an end to thirst, the promise of new plant growth, the promise of returning animals. It was, quite simply, the smell of survival. This deep, instinctual love for the scent of rain is a part of our shared human heritage, a chemical memory passed down through countless generations. This scent is the promise of life. But what of the life that is born directly from the rain itself, the life that awakens with the storm? What happens in a desert, in the moments and days after the rain finally comes? A desert, to the casual observer, can seem like a landscape defined by absence, a place that is largely devoid of life. The ground is hard, cracked, and baked by the sun. The plants are sparse, thorny, and grey. The silence is broken only by the wind. It can feel like a world in waiting, but a world that is waiting for something that may never arrive. But then, it does. A great, dark storm rolls in, and for the first time in a year, or perhaps in a decade, the rain begins to fall. It falls hard and fast, and the thirsty ground drinks it in. The hard-baked clay softens. The air, once shimmering with heat, grows cool and heavy with the scent of petrichor. And in the days that follow this blessed event, a miracle occurs. The desert, which was a canvas of brown and grey, begins to transform. A faint green fuzz appears on the hillsides, which soon deepens into a vibrant, verdant carpet. And then, almost overnight, the landscape explodes into a riot of impossible colour. Vast swathes of purple, yellow and orange wildflowers erupt from the ground, a phenomenon so spectacular it is often called a superbloom. The air, once silent, is now filled with the drowsy buzz of countless insects and the calls of birds that have arrived to feast on them. The desert is not dead, it was only sleeping. This spectacular transformation is made possible by a brilliant and patient survival strategy. The wildflowers that create the superbloom are known as ephemerals, or annuals. Their life cycle is short and fast, lived entirely within the brief window of opportunity that the rain provides. For most of their existence, they are not plants at all, but seeds, sleeping in the dry soil. This collection of dormant seeds is called the seed bank, and it can contain the potential for thousands of plants in a single square meter of desert soil. Each seed is protected by a tough, durable coat, and it can lie dormant, perfectly viable, for decades, waiting for the precise signal to awaken. That signal is not just any rain. A brief shower might not be enough to sustain the plant through its full life cycle. so the seeds have evolved to be patient. Many require a significant, prolonged downpour to wash away a growth-inhibiting chemical from their seed coats, ensuring that they only germinate when the soil is deeply saturated. When that signal finally arrives, they all spring to life at once, racing to grow, flower, and produce new seeds in just a few short weeks, before the sun reclaims the land once more. And it is not just the flowers that awaken. The very soil itself comes to life. Much of the desert's surface is covered by something called a cryptobiotic crust. When dry, it looks like a lumpy, blackened, and lifeless layer of dirt. But it is, in fact, a complex and fragile community of cyanobacteria, mosses, lichens, and fungi. During the dry times, this community is completely dormant. But when the rain arrives, it awakens, turning into a spongy, dark green living mat. It photosynthesizes, producing energy and releasing oxygen. It fixes nitrogen from the atmosphere, a natural fertilizer that enriches the soil for the ephemeral plants. And its spongy texture helps to absorb the rainwater, preventing erosion. This living skin of the desert is the foundation of the entire ecosystem. The animals, too, have been waiting. The spadefoot toad, which has spent the last year or more buried deep underground in a state of suspended animation, feels the vibrations of the falling rain and begins to dig its way to the surface. It will emerge into this transformed world to feed, mate, and lay its eggs in the temporary pools that have formed a frantic and joyous celebration of life. In these same pools, the microscopic eggs of fairy shrimp, which may have lain dormant in the dry dust for 20 years, will hatch, creating a teeming, instant ecosystem of tiny crustaceans. The rain, we see, is not a creator of life. The life was there all along, hidden, patient, and full of potential. The rain is the awakener. It is the key that unlocks the incredible vitality that was sleeping just beneath the surface, a testament to the enduring and often invisible power of life to persist in the most extreme of environments. We have seen the rain awaken the land, transforming it from a silent desert into a vibrant garden. But what of its effect on us, on our own minds and spirits? Why do we find such deep and abiding peace in the simple sound of its falling? Why does the sound of rain on a roof feel like a lullaby? After witnessing the explosive awakening of the desert, we turn our gaze inward, to the quiet and subtle effect that rain has on our own human consciousness. There is a deep and almost universal comfort in the experience of a rainy day, the feeling of being safe and warm inside while the world outside is being washed clean. The windows are streaked with water, blurring the sharp edges of the world into a soft, impressionistic painting. The steady, rhythmic drumming on the roof and the glass creates a sense of enclosure, a sonic blanket that wraps around our home and separates us from the world outside. It is a day that seems to invite slowness, to encourage us to set aside our busy schedules and our endless lists of tasks. It is a day for a warm drink, a comfortable chair, and a good book. It is a day for introspection. Part of this profound calming effect is purely acoustical. The sound of rainfall is not silence, but it is a kind of noise that our brains interpret as deeply non-threatening. Scientists who study sound categorize different types of noise by their frequency spectrum. White noise, like the static from an old television, contains equal intensity at all frequencies, which can be harsh and jarring. The sound of rain, however, is closer to something called pink noise. Pink noise is more intense at the lower end of the frequency spectrum, and its intensity decreases as the frequency gets higher. This is a sound profile that the human ear and brain find particularly soothing and natural. It is a steady, consistent, and broadband sound, meaning it covers a wide range of frequencies. This quality allows it to act as a wonderful acoustic mask, covering up other, more sudden and disruptive noises from our environment. A passing car, a slamming door, a distant siren. The rain's gentle, constant shushing sound smooths out our auditory world, removing potential alarms and surprises, and allowing our nervous system to relax, to let down its guard. There is also a chemical element to the tranquility of a rainy day. Have you ever noticed how the air after a thunderstorm feels fresher, cleaner, and somehow more vibrant? Part of this is the literal washing of dust from the air, But some scientists believe it is also due to the presence of negative ions. An ion is simply an atom or molecule that has an electrical charge. Negative ions are created in nature by the violent collision of water molecules, a process that happens in crashing surf, at the base of a great waterfall, and during a rainstorm. Lightning is also a prolific generator of negative ions. Some research has suggested that inhaling air with a higher concentration of these negative ions can have a positive effect on our mood, potentially boosting serotonin levels, reducing stress, and promoting a sense of well-being. The fresh, clean feeling of the air after a storm may be our bodies responding to this subtle shift in the electrical charge of the atmosphere. But perhaps the most powerful effect of a rainy day is psychological. In our modern lives, we are often driven by a sense of obligation to be productive, to be active, to be outdoors. A sunny day can bring with it a subtle pressure to make the most of it. A rainy day graciously absolves us of this pressure. It provides a natural and guilt-free excuse to cancel plans, to stay home, to turn inward. The world outside shrinks, and our inner world is given the space to expand. It is a time for quiet contemplation, for creative thought, for reconnecting with ourselves or with loved ones in a cozy, protected space. The rain gives us permission to rest. It is a gift of slowness in a world that is always demanding speed. It reminds us that periods of quiet, fallow introspection are not a waste of time, but are as essential to our well-being as the rain is to the health of the soil. Our journey began on a world of perfect, unchanging stillness, a world of unbroken blue. It ends here, in this gentle, enclosed, and life-giving rhythm of a rainy day. What have we truly learned? What have we come to appreciate by imagining a world defined by its absence? After so long on a planet without rain, what a strange and beautiful thing a grey sky is. We began our journey by imagining a sky of flawless, sterile, and unchanging blue, a sky that we saw as a kind of beautiful perfection. But now, returning home, we look up at a soft, uniform, grey canopy, and we see it not as a gloomy or imperfect thing, but as a sky full of promise. It is a sky that is alive, a sky that is in the process of doing something beautiful. Let us watch, for a final time, as the rain begins to fall. It lands on the deep green leaves of a forest, each drop a tiny, shimmering jewel. It darkens the asphalt of a quiet city street, reflecting the warm lights of the buildings in long, slick ribbons. It touches the surface of a still lake, creating 1,000 ever-expanding, interlocking circles, a complex and beautiful pattern that lasts for only a moment. The sound, the smell, the very feeling of the cool, damp air on our skin is no longer just weather. After our long journey through the cosmos of the dry, we can now recognize it for what it truly is, a quiet and profound miracle. This simple fall of rain is the linchpin that holds our entire living world together. It is the visible manifestation of the water cycle, the great planetary engine that connects the oceans to the atmosphere and the atmosphere to the land. It is the force that sculpts our world, not with the harsh abrasion of the wind we saw on Mars, but with the patient, life-giving chemistry of water, carving the gentle valleys and fertile plains that cradle our civilizations. It is the breath that washes our atmosphere clean, scrubbing the air of its dust and impurities, a constant renewal that our imagined, unwashed world could never know. And it is the messenger that awakens life, triggering the explosion of the desert bloom and sustaining the quiet, constant, and deep-rooted life of the entire planet. We have seen that the conditions for this miracle are fantastically rare. The universe is filled with worlds that are too hot, too cold, too small, or too unprotected to host this gentle phenomenon. The narrow sliver of possibility, the perfect confluence of the right distance from a star, the right size, the right chemistry, and the right geological history, has made our world a stunning exception. And in this, we learn the most important lesson of our journey. The profound and quiet beauty of imperfection. The perfect, unchanging blue sky of our imagination was a sterile and static thing. It is the dynamic, ever-changing, and beautifully imperfect nature of our own cloudy, rainy sky that makes it a living thing. The clouds, the storms, the unpredictability. These are not flaws in the system. They are the very engine of a vibrant and resilient world. And so our thought experiment, our journey to a planet without rain, has taught us the gift of gratitude through absence. By imagining a world that does not have this thing that we so often take for granted, we have learned to see it again for the first time. We have come to appreciate the deep comfort in the sound of its falling, the complex beauty in the scent it releases, and the incredible, life-giving power contained within a single, humble drop. The simple molecule of H2O, two atoms of hydrogen bonded to one of oxygen, is one of the most common substances in the universe. But in its liquid form, flowing freely on the surface of a temperate planet, it is perhaps the most precious substance in the cosmos. It is the difference between a silent, dusty rock and a singing, living, breathing world. It is the difference between a gallery of beautiful but lifeless planets and our home. As the sound of the gentle rain continues to fall, I hope it brings you a sense of deep peace and tranquility. Thank you for joining me on this long and quiet journey tonight. If you found this story soothing or thought-provoking, please do consider liking this video and subscribing to the channel. And I would love to read your thoughts in the comments below, perhaps a memory of a rainy day or a reflection from our journey. It is always a joy to hear from you. Until next time, may your rest be deep and your dreams be peaceful.